Hi, hello, and welcome. We are broadcasting live from Global Council for Aerospace, Defense, and Deep Tech Innovation. A prime global platform decided to accelerating innovation, strategic partnership, and cross-border collaboration across aerospace, defense, and deep tech industries. Today, we are witnessing a profound transformation in the global strategic landscape, breakthroughs in space technologies, autonomous systems, satellite intelligence, advanced manufacturing, quantum computing, artificial intelligence, cybersecurity, and defense innovation are redefining the future of national security, industrial competitiveness, and global economic growth. Yet, alongside this technological revolution comes a significant challenge. Governments, defense organizations, investors, and enterprises are navigating an increasingly complex ecosystem filled with fragmented technologies, evolving regulations, and rapidly shifting geopolitical priorities. Visionary founders or breakthroughs innovators often struggle to access the strategic partnership, institutional capital, and global market opportunities needed to scale their solutions. Promoted by the Global Council for the Promotion of International Trade and supported by the global network of polymakers, defense leaders, researchers, investors, and industry experts established to bridge the gaps and create a trusted ecosystem where innovation can move seamlessly from concept to deployment. We are more than a platform, we are a catalyst from collaboration connecting governments, defense organizations, space agencies, investors, enterprises, startups, and research institutes to accelerate commercialization, strengthen sovereign capabilities, and build the technologies that will define the future. Operating across key strategic regions including India, the Middle East, Europe, North America, Africa, and the Asia Pacific, Global Council for Aerospace Defense and Deep Tech Innovation is committed to fostering partnerships that drive technological resilience, economic growth, and global competitiveness. Today, as part of our visionary interview series, we are exploring the ideas and innovations shaping the future of aerospace, defense, and deep tech. Joining us as a leader who embodies exactly what it means to build the vision, purpose, and transformative impact. Please join me in welcoming our distinguished speaker, Mr. Atul Srivastava. Atul Srivastava is the Vice President of Votary Softech Solutions Pvt Ltd and a seasoned technology leader with more than 2 decades of experience at the intersection of robotics, autonomous systems, advanced sensors, embedded software, edge computing, energy systems, and artificial intelligence. With global experience spanning the USA, the UK, Singapore, France, Switzerland, and China, Atul has been in- instrumental in driving innovation in advanced manufacturing, supply chain transformation, and deep tech solutions. His expertise include application-specific humanoid robotics, next-generation battery technologies, semiconductor-enabled AI platforms, and intelligent systems powered by advanced sensors and edge intelligence. Passionate about building the future ready technologies, Atul has focused on leveraging system on chip architectures, integrating CPU, GPU, and NPU capabilities, and creating intelligent solutions that redefine aerospace, defense, and industrial applications. Atul, thank you for joining us today to help the shape of the future of the Global Council for the Aerospace, Defense, and Deep Tech Innovation.
Pleasure, my friend.
So, I'd like to ask you a few questions to explore your vision and expertise in greater depth. Moving to my first question, with your extensive experience in robotics, embedded systems, advanced sensors, and AI, how do you see autonomous systems and intelligence machines transforming aerospace, defense, and industrial sectors over the next decade?
Okay, so there are various domains in deep tech domain, and starting with say humanoid itself. So humanoid actually will not be looking exactly like humans. These are basically general purpose robots, which are used for areas where it can be hazardous or can be emergency areas or for defense and all, and for a specific purpose. So it's not like it will like humans and all. And they are from the deep tech domain, and compared to this domain, so fundamentally it's based on just motors and special material limbs and batteries. So these are the deep tech technologies we are presently using for this humanoid domain.
Thank
And
you.
there are other domains also, like aerospace domain. and I've been interacting, say, aerospace areas since 1989 with General Electric gas turbine domains and all. So what is important here is that in the aerospace, what is most important thing is software. Okay, and for the software domain, from very beginning and very fast say hardware is required. So we are working in those domains, that starting from different domains, so whatever is the fighter aircrafts also. So how we can utilize the very fast say processing chips, like where we just now mentioned that, okay, you are using combination of your CPU, GPU and PU together, that kind of very fast processing that can be done, and a lot of using of AI. So many of these fighter planes are basically designed almost 10 to 15-year old. So we can utilize the latest technology, and whatever is the next generation technology we can outcome. So we are working on these many domains, whatever you have just mentioned. Yeah.
Yes. Thank you. Thank you for sharing that perspective. Intelligent autonomous systems are undoubtedly reshaping the future of industries worldwide. So let's move on. Our next question. You have worked extensively on manufacturing and supply chain innovation, including advanced battery technologies and intelligent hardware platforms. What are the biggest opportunities and challenges in building resilient technology driven manufacturing ecosystems?
Yeah, so supply chain as on today is very fragmented. Okay, so if we look back for say the supply chain used to be very strong even in say early 90s and all, but over the years also what has happened. So for manufacturing, whatever new technologies we are using, so apart from technology, how we can transform the advanced supply chain. So we have to create many companies, maybe called as the ancillary companies or the vendors or suppliers, which can be. So if you work in any advanced countries, it's one company can give all the subcomponents and all. So we have to create a very strong supply chain community here. And also manufacturing also is using latest technologies. So latest technologies from say hardware. Apart from that, okay, robotics using for even manufacturing purpose and all. So that and even for say certification for this thing, testing, automation testing and all. So we have to create entire ecosystem for manufacturing. Presently, this is dependence on many countries for the country. So what we should use it, we should do manufacturing, which should be as advanced as any other country. And since we have some kind of big gap in manufacturing domain and all, so how we can utilize this gap and try to do some innovation, that how we can do advanced manufacturing. So a lot of work is happening. But if you are looking specifically for aerospace and defense and all, for that there's a lot of work is needed, and we are working on those domains also.
Yeah. That's fascinating insight. The convergence of the manufacturing and deep technologies will play a critical role in shaping the future of industries. So, moving to our next question, with the rapid evolution of semiconductor technologies and system on chip architectures, integrating CPU, GPU, and NPU capabilities, how do you envision these innovations accelerating the adoption of AI powered solutions across aerospace, defense, and robotics?
So it's a very pertinent question. So a semiconductor, we are already using advanced semiconductor in many applications in the country, but we are importing those semiconductor things. But presently, a lot of activity is happening in within India itself. Semiconductor chips are being designed and all. So what link is required, that whatever applications we are having for aerospace and defense, we should work already working with existing semiconductor companies in the country. And generally, the design cycle and manufacturing cycle takes 3 to 4 years. So this is the correct time that all the aerospace and defense related whatever designs. So we are in say 2026. So what is to be designed in 2029, we should discuss with existing semiconductor companies in the country itself. So otherwise, if you want to say, if they don't know, they cannot be a part of our own ecosystem. So for whatever we are saying that Atmanirbhar or country self-reliance target and all, we should start working with all the semiconductor companies presently in the country and work with all the design companies together. So that's the correct thing.
Yeah. Thank you for highlighting the importance of semiconductor innovations. It is clear that next generation computing platforms will become the backbone of intelligent systems. So let's move to our next question. Humanoid robots and applications specific autonomous systems are gaining momentum across industries. Which real world applications do you believe will see the fastest adoption over the next 3 to 5 years, and what technologies breakthroughs are still needed?
So, from the humanoid point of view, if you see for China, they are presently having more than about 100,000 robots for manufacturing. So, looking into that, we can also the first applications for humanoid. They may not look like humanoid, but we can call it like humanoid and all. So for that, humanoids for manufacturing is going to be the first applications, and that is required in the sense, and especially for again, say we are say aerospace or defense and automotive. So these are the three areas where where for humanoid applications is going to be the first targets. And uh, what is happening that there are applications where it has to be a large repetitive applications. So for those kind of things, using robot makes the error prone is not there because mistakes will be less. Even for to that extent, they are trying for even textile industry also. They are trying robots for certain applications which takes too much consuming time. Okay, so those kind of applications are going to be first target for humanoid.
Yeah, thank you. That's an exciting perspective that future of robotics and intelligence automation holds tremendous potential across multiple sectors. Moving to our next question. India is increasingly focusing on self resilience in aerospace and defense technologies. From your perspective, what role will indigenous innovation in robotics, sensors, and semiconductor technologies play in strengthening national capabilities over the next decade?
So again, coming to we can focus on defense because India is importing uh, very large quantity of items are getting imported. So we can so for the self-reliance things and all. The first thing is for defense related. So why deep tech is important? Because what happened that instead of making some subsystems or small changes or some small part, that should not be the focus. The focus should be a very deep understanding of the actual what are the weapon systems are there, what are the technologies, which are the technologists and engineers, what are the. So initially we need not focus on the cost itself, that okay we should be having just similar to what say DRDO is doing, but not only DRDO, it can be many such companies, because so there should be even the government or the private is not important. What is important is the number of technologists and engineers who have good understanding of not only today's weapon designs, only for even the future designs and all. So as we have seen in the present geopolitical context, whatever your existing weapon countries or the defense systems and all is not enough. That is going to be different. So it's good timing for us in this domain and this platform what we are discussing, that let us design some new technologies, whatever is there, and let us design from scratch from Indian engineers and technology scientists within India itself. And that is a very good opportunity for us to whatever is the self-reliance theme. But many times what happened, the issue is what is the overall momentum is reducing is because a lot of people are claiming as a self-reliance, but actually they are not self-reliant. So what important is understanding correctly which are the companies, which are the agencies which are doing actual the real deep tech technology research work is doing, and what they are transforming for future. So this is very pertinent question for this domain also.
Yeah, thank you for sharing those insights. Building capabilities in critical technologies will be essential for creating resilient and globally competitive aerospace and defense ecosystem. So let's move our next question. Edge computing and real-time decision making are becoming crucial for mission critical operations. How do you see edge intelligence transforming autonomous platforms in areas such as surveillance, logistics, and defense operations?
So edge computing is say last 2 3 years, edge computing has become important because there's too much reliance on cloud computing. Okay, so cloud computing with say edge computing has become the prominence because the intelligence can be local itself. So whatever we are doing in the different domains, whatever you mentioned about logistics or any domain or even the medical equipment. So for example, say even if we are talking about say medical equipment or the defense equipment and all, so you should not be, say, suppose you are doing surgery and you want to do some cloud, some 5G connectivity, some that's not the correct way of doing it and all. So why edge processing has become even for the industrial applications that okay, lot of intelligence should be, and including your natural intelligence as well as AI based decision taking should be local. And that's why you say that why you mentioned that okay, apart from CPU and GPU, NPU was there because we can do local processing itself. And certain things which is required to database or very large computing in such kind of scenarios, then in that case cloud computing. So it's not that we are going away from cloud computing. Cloud computing exists, but edge computing for many applications where local intelligence is a must. Even for agriculture and all, suppose you say crop related, anything related to, you want to understand when to water, what is pesticide and all, everything dependence on cloud is not correct. So whichever application, it can be many applications, and that's why more and more say from the SoC semiconductor side, a lot of focus on edge computing is there. So edge computing is a correct timing, and we can see decide based on applications what part of it can be done at edge computing, what can be through cloud computing. It can be decided, or it can be a mix of that also.
Yeah, that's a fascinating perspective. The ability to process and act on data in real time will undoubtedly redefine how intelligent systems operate in complex environments. So, moving to next question, you have extensive experience working across multiple international markets. What lessons can startup and deep tech companies learn when scaling advanced technologies from research labs to global commercial markets?
Yes, so international exposure is very important, and you should be learning. And so I can give you two different applications. One is from Taiwan, another one from Switzerland. So when I visited Taiwan, so what is, and there is a very big ecosystem is there. Okay, so you say that okay, Hsinchu is the place in Taiwan, and where there are so many companies are there which are researching and saying deep tech domain and all, and there is various companies are developing many products and all those things. And you can understand that due to this kind of country like Taiwan, now semiconductor, that is the number one, okay, from the semiconductor domain. So I visited them in say in year 2026 years back, and I saw that okay, what is importance of creating in science and technology community. So like in India also we can see there are many communities are there in say many like Bangalore and Hyderabad and other cities there is there, but connected community for technology at a central place. Okay, if I remember, it was a science tech park in Sinchu, so that's the place. So that is one learning from there, that okay, we should be having from say international exposure side, like Taiwan. We saw there's a big communities there, and even though Taiwan is a small country, how they dream big. So that's one thing. And
Yes.
my other came from my Switzerland. I was in 1992 in Switzerland for about 6 months, and that was working with ABB. And they say that okay, lot of things it takes time. Like they started in 1905, and how they developed. Earlier it was like a village there near Baden, and how they developed, and then we say it became like a manufacturing powerhouse. So you say that okay, countries can be small, like two examples you've taken. Say even if the countries are there, they may be that time around 60 lakh population for the entire Switzerland, but they dream big what they can contribute internationally, how they can become important. So if we are such a big country and all, and how we can impact globally. So we can see that okay, if you big countries certainly. So I have a worked and interacted with many countries like Japan, France, UK, USA, and all. And everywhere you can learn, okay, from different what are the best practices. So exposure is certainly very good. And what learning, overall learning is India has everything inside itself. We don't need any other country. Everything is available in the country. How we want to do it, it is up to us. And this is correct timing. All these discussions we are doing. So we need not looking for any other country. Why other country doing? If the small countries can do big, why not India itself? So that's the conclusion, that okay, let us do it in India. Why in other countries?
Yes, that's true. Thank you for highlighting those important lessons. Successfully commercializing deep tech innovations required not only technical excellence but also strong partnerships. So let's move to our next question. Advanced sensors generate enormous amounts of data that can improve decision making in aerospace and defense. How do you see the combination of sensors, AI, and predictive analytics changing the future of mission planning and operational efficiency?
So that is related to what we discussed earlier itself, that okay, any advanced sensors means there will be a lot of data will be there, and we can do that processing at the sensor itself, or processing at the edge itself. So what we can send to cloud, or any other systems, okay, we can send the process data, so that everybody is not interacting lot of data. So one conclusion for all advanced sensors is that. Secondly, sensors apart from local processing, there there can be intelligence also there. So we are saying that okay, there are a lot of, again, like we want to do some processing locally. We can do intelligence also. So what is data is there, and again, say in case of aerospace and all, we have earlier interacted with say onboard computing is there. So when any kind of missiles and all is being say, so there has to be computing locally, sensors has to be calculated locally. So all these kind of things, luckily there is a low cost, high performance chips are available, SoCs are available. So we can do, we can whatever data, in case more data is there, corresponding thing is there is a more processing is also there. So there's no handicap that okay, more data from sensors. So we can do all those three things together, that okay, we can do local intelligence, we can be AI based sensors, as well as there should be computing, we should be powerful computing. So all those things together. And we need more sensors coming years, because for many years the sensors were there, and a lot of research has not been done on the sensor side. So there is a lot of especially wireless sensors and all for medical and such domains and all is required, because for still say for healthcare, if you want any data from diagnostics for your own body, it's a very cumbersome process of getting diagnostic done and all. So there is a time for new generation sensors, more advanced sensor, AI based sensors, local processing. So a lot of work has to be done on the sensor itself.
Yeah. Thanks. Thank you for excellent those points. So before we conclude, one final question. GCADI aims to build a global ecosystem connecting aerospace and defense and innovators, enterprise researchers, investors, and policymakers. How can organizations such as Votary Softech collaborate with GCADI and accelerate the development and commercialization of next generation technologies?
So this is very important that this is a connected community of all the researchers, scientists, technologists, engineers. Okay, so that should be there. So this is a correct this kind of forum where they interact on say maybe every 6 months they can interact together, and they should be interacting the ideas. Okay, so presently what we know that okay, this kind of community is there are forums, okay, but regularly interacting and working together collaboration is very important, because uh, any advanced domain requires many parts. Okay, somebody may be computing, somebody may be doing sensor, somebody may be material science, and also there are many, at least 5 to 6 domains are there. And for each 5 to 6 domains, again there are specializations, each one so we can easily say that any domain, say aerospace, can be at least 200 kind of companies which may be working together. So there should be a forum, and they should be interacting together and collaborating each other. So that is the need of the hour. So this is my final conclusion, that okay, there should be a community, there should be connected community which interact and collaborate with each other, and create products which are good for the country.
Yeah, thank you for sharing your vision, your insights. So, what an exceptional and insightful conversation. Thank you, Atul, for sharing your
Thanks here,
valuable
and it was
expertise.
very nice interacting with you, and it was very informative questions also.
Yeah.
Thanks for that.
Yeah, thank you, and sharing your valuable expertise and inspiring vision with the GCADI community. So, on behalf of the entire Global Council for Aerospace and Deep Tech Innovation community, thank you once again for joining us today. We look forward to witnessing your journey and its contribution to shaping the future of aerospace, defense, and deep tech innovation. Thank you for joining us today. Until next time, keep innovative, keep collaborating, and together let's build a stronger, more secure, and technological advanced future. Thank you for joining us today, Atul.
Thanks for connecting. Thanks.